Hello, everyone. Welcome to the July 2013 edition of the Professor Messer Network Plus Study Group. This is a study group we like to do or try to do once a month. We've had a few months off here, but now that it's summer, now that we can take a breath and have a look at what's ahead of us, I've decided, yes, it's time to do another study group. So we'll try to get these going every month. And I really should, because every time I ask for your questions, you send me a ton of them. And so it's the same as a previous group. I've got plenty of information to go through, plenty of things to talk about. I'll be taking your questions that you've sent me during the month, and we'll be looking at some of the most popular ones that have come in. If you're watching this live, you will have a link at the bottom of the Professor Messer website. There's a chat that's across the bottom. That is where I'm looking at the live chat. So if you're watching this live on YouTube, unfortunately, I can't see the YouTube chat that's going on there, but you can go to the Professor Messer website and see the chat there as well. The idea behind this study group is to take your questions, think about what you need to know for the exam, and go from there. And we couldn't do this without your support. For those of you that watch our videos, every single one of my Network Plus videos, my A Plus videos, my Security Plus, all the videos I make, I put on YouTube. You can watch them absolutely free every minute of every video I put out there so that you can get the entire course, not just samples of the course, not just a little bit of what's available. I just put them all out there. So one of the things that's very useful, though, is some of you need an offline version of the course. So if you're in a situation where you're driving in your car and you'd like to get MP3 files to listen to, maybe you'd like PDF versions of the slides, or maybe you just like to watch the videos offline, I have DVD-ROMs that have this entire course available to you. You can go to professormesser.com/download-network plus and see all of those. I like to also keep everybody up to date on what's going on. So if you'd like to follow us on Twitter and on YouTube, you can follow those links at professormesser.com/Twitter and professormesser.com/YouTube as well. There is quite a bit we're doing this month, but in our last study group, there were a number of things that we went over as well. Had quite a few questions that people were asking. One was, don't virtual machines still need a physical connection to the network? Can you explain more about routing metrics? What is encapsulation? There was a big conversation we did with tunneling. I even threw in a little bit of IPsec into that. What are some uses? NTP was one of the acronyms we went through. The question about the exam itself. We don't just talk about technology in this particular training course. We talk about how to take the exam. And we talked about things that you would need to know or not need to know on the exam, including the RFC numbers. And if I was going to skip Network Plus and go straight to Security Plus, is that a good idea? If you have these questions, and I know you do because a number of you sent me these questions again this month, you just have to go back to the previous one. You can find all the study group replays at the bottom of the Network Plus index, the huge library that I have on my website. A quick link to that would be freenetworkplus.com. FREE network plus.com takes you right to the page. Makes it easy. So that's one of the things that we like to do. Now, if you have your Network Plus certification and you're trying to keep that certification because it does expire after 3 years unless you renew it, and if you want to renew it, then you probably should have a look at things like the renewal policy that's on the CompTIA website. You can do continuing education unit, CEUs, to keep and maintain that certification. And so if that's interesting for you, you can go out to CompTIA's website because you get credit just by watching this study group, which is kind of nice as well. This is one of those things that a lot of people like to be able to simply do the things they normally do in their job. I think most people will probably renew their certification by taking a higher level certification, which is another way to easily renew. You don't have to do these continuing education units if you don't want to. If you have Network Plus and you'd like to renew it, just take Security Plus. Just take one of about 30 or 40 or 50 different certifications from other companies, and they will renew your CompTIA certifications. There's a big list out there on the CompTIA website for their renewal information. So if you look for the renewal FAQ, or you go to their website and look at renewal, that is absolutely a place you should go and be able to see that and everything that's going on there. So we have a number of things to do today, but I like this to be interactive. Some folks saw this during the pre-show saying, what's the voting thing? What is that about? Well, I like to ask you questions. I'd like to get feedback from you. And I do have some questions and answers that we get to do today. So you can pop open a new tab on your screen, open a new browser window, or use your mobile device. There's a vot.rs is the website, vot.rs, and you type in this code 972984, or perhaps in maybe the only time a QR code may ever be useful to you. If you have a QR code reader pointed at your screen, it will take you right to the page, exactly where you need to go. So that is one of the things that will take you to a voting page. And when you get to that voting page, you can vote on this question. And I asked the question of your Network Plus certification because I'm interested in hearing your ideas around how you're studying. And if you look at less than 3 months, 3 to 6 months, 6 to 9 months, 9 months to a year, and over a year, I'm looking for your feedback on how you're able to see that certification work for you, how long you've been studying. And it's interesting, we get kind of a mix on our study groups of people that have been doing this a little bit, people that have been doing this a lot. And I realize there is a bit of a delay on the stream. If you're watching this live, you're still about 60 seconds behind me. It's not an instantaneous type thing. So you'll start to see these things trickle in. And really, you're seeing this about a minute after it really happened. So you can see now everybody, now that I've talked a little bit, everybody's starting to vote on the responses that they have here. I think we can probably go ahead and look at these responses that we have on this screen. Let's go ahead and show the results. Be useful to know what is it that you have, and indeed less than 3 months for your folks working on your Network Plus. I think during the summer I see a lot of this. I see a lot of people who are working on their certifications, trying to prepare and get through the summer with maybe a new certification at the end of this. And some folks always, this is probably the real world kicking in. You can see over a year. Some folks have been studying this for a while, and I suspect it's probably been you've started studying on it and then you had to stop. Real world got in the way. There were things happening in your life, and now you're back into that again. I get emails all the time from you folks who send me messages and say, I'm starting this back up. Have there been any changes since a year ago? We talk about if there have been or perhaps if there hasn't been. So quite a few of you, less than 3 months. I think a lot of the questions that we have ready for you today will absolutely address some of the things that you're going to want to know about and prepare about for your Network Plus certification. And we'll talk about not just things you're doing with your studies, but also what you really should expect when you're ready to go in for your exam. But let's first go to the questions you have about the exam content. And before we do that, we're going to test out, now that you're used to answering these questions on our quiz, our interactive quiz, I have a question for you. And the question is, what encryption algorithms are used by public key cryptography? Now, the real question I have is, did I actually put these in here on the front end that I have? Actually, this may take you to a different question. We may just skip through this one. I've scrambled around on my screen all of these to see if this is really the case. I'm going to pull it up and have a look. And if you go to 419274, sometimes when you're moving things around, yep, that's a wrong one. So unfortunately, we're going to have to skip that one. That's live television for you people. This is one of the things I mentioned in the pre-show, that I've completely rearranged my office between the last study group and this one. And you should have seen me last night plugging things in and making sure that all of the different things I was looking for were going to be on here. And unfortunately, I happened to miss that particular quiz question. So one of the things that, let's answer the question though. Let's go back. You're probably new, right? It's not a total loss. What encryption algorithms are used by public key cryptography? The reason I asked that is this, because someone asked the question, what's the difference between asymmetric and symmetric? And of course, they kind of left it generic. Like, what is the difference there? The chat room's complaining. No, it's not the right question. Well, you can answer that question if you'd like, since you're there. We're going to get to that in just a bit. Difference between asymmetric and symmetric. And in networking, or at least the topics associated with networking on the Network Plus exam, this could mean a couple of different things. for folks that are doing a lot of networking, especially in large environments where you have multiple connections, they're going to multiple links out on the internet. Traffic may go out one connection and come in another. That's an asymmetric type communication. But in the case of Network Plus, you don't really talk a lot about symmetric and asymmetric traffic flows. What you're normally talking about with Network Plus, and if you look at the exam requirements, we're really talking about symmetric and asymmetric encryption types. So I'm going to focus on that particular piece. The way that we deal with encryption overall, at least in the very, very, very historic way, was through something called a symmetric cipher. And you can think about symmetric encryption, where is something where you have a particular key or a code word that you've encrypted something with. And on the other side, that person has to know that key or that code word to be able to decrypt it. Think of the bad guys or the spies that are traveling around the world with all of their pieces of information. They've got a briefcase and it's been locked on one side. The person has the key on one side and the person with the briefcase doesn't have the key. They travel to the other country. They set the briefcase down. On the other country, that person on the other side has to have exactly the same key to open up that briefcase. They can't use a different key. The briefcase won't open. That's a symmetric cipher. That's a symmetric lock. The ability to encrypt it, the key that's used is exactly the same as the key that's used to decrypt it. But in asymmetric encryption, it's not quite the same thing, is it? You may hear this referred to also as public key cryptography. But this asymmetric means that you encrypt it with one key, you decrypt it with a completely different key. That's a little crazy just to think about. How does that even happen? How does that even work? And in fact, this asymmetric encryption is a relatively new technology. This is something that's only been around 20 years, maybe a little bit more, maybe a little bit less. I should probably be a little bit better with my history, but we aren't talking about something that's been around for 100 years. This is a brand new, in the world of cryptography anyway, way of doing things where you have to have, there's a lot of randomization. It deals a lot with very large prime numbers. So of course you need some type of computer to be able to handle those types of things. There's a lot of cryptography involved here. Just the idea of encrypting with one key and decrypting with another. Wow, that's a little extreme. So of course it's going to be relatively complex. When you work with this type of encryption, what you normally would do is you build these keys yourself. You build a private key for yourself. That's just like your private key ring, just like the keys for your car. You wouldn't give keys to your car to everybody. You hold those keys for yourself. Then along with that, at the same time, you're creating a pair of keys. The other pair is a private key. That's the key that you give to everybody. And you say, if you're ever going to encrypt anything and send it to me, encrypt it with that public key that I'm putting out there. It's public. It's everybody's. They encrypt it with that public key. And then once they send it to you, the only way to decrypt it is with the private key. You can't decrypt it with the public key. You can only encrypt with the public key. Really a quite remarkable way of doing this. Very useful to have this here. And it is part of your Network Plus certification. So you will want to be sure to look through your exam requirements. And we don't get a lot into encryption in the Network Plus, but there is a little bit. It kind of prepares you for Security Plus. Now in the Security Plus exam, lots of encryption, a lot of things you have to know about symmetric ciphers, asymmetric ciphers, hashing. There's only a little bit of this, and the public key cryptography is the section of the Network Plus that you have to know how this works. So I think that's one of the things that as you start working through using this, you may want to yourself try some public key cryptography. One of the well-known applications to do this in the world has always been PGP. These days, a lot of people use GPG to be able to do that, which is the similar technology, but it's in an open source type of platform. PGP is a product that was created by Phil Zimmerman, and it is, I believe it's now owned by Symantec. So if you want to use something that's open source, and a lot of people do, look for GPG. I can probably find this for you. Since we're doing this right here, I can probably find the website for you and pull this up. I know you can't see this right here, but I'm I'm hunting things down just to make sure I don't give you the wrong website. GNU Privacy Guard is at GNUPG.org. GNUPG.org, GNU Privacy Guard. And that is where you will find all of those. If you want to play around with this yourself, you want to really learn about this public key cryptography, that's where you will find it at GNUPG.org. Did I say org or .com? It's .org. You guys can keep me honest in the chat rooms with the things that I'm doing with that. So it's a very interesting technology to me. Whenever I've gotten into encryption and decryption, especially with public key cryptography, it's really quite amazing. And once you start understanding the things you can do with it, not just the encryption, but digitally sign something. Don't encrypt it. Make it so that everybody can read it, but you put a code at the bottom that guarantees that it is in exactly the same form that it was when you signed it. Nobody can modify anything in there. You can really validate those things. Really, really fun to do some of those things. So I highly recommend that you do some of those as well. Now, I'm going to make sure before I tell you the next question that I actually have it correct. So we're coming up on a question. Get your viewers ready, your QR code readers ready. So I have another question for all of you. And that question is, in TCP/IP, what's a gateway? What is a gateway? Now, I gave you some options for this one. This one actually works. I can promise you that it works. So take your snapshots with your QR code reader now, flip over. But the options are, is a gateway a server that provides automatic IP addressing? Is it the destination address for all non-local traffic? Is it an intermediary server that processes internet requests? Or is it a repository of encryption certificates? What is it? What is that? You guys can think about that one. I'm going to take a sip. Okay. So when you get to this, you really have to think about this. This question came because somebody was asking questions about a gateway, and we're going to talk more about that in a moment. But it really gets into how TCP/IP works. That's why I specified in this question in the TCP/IP world. Because in networking, the word gateway can mean so many different things. But when we're just talking about TCP/IP, what is it? Don't answer this in the chat room. Don't cheat. Don't spoil it. Everybody respond with the answer that you have. Is it a server that provides automatic IP addressing? Is it the destination address for all non-local traffic? Is it an intermediary server that processes internet requests? If you go to vot.rs and use the number 698898, that's vot.rs, the number 698898, or you can click on that. Put it up for a couple seconds. You can point that at the screen. vot.rs 6988. I guess I can even make this a little bit easier for everybody. 698898. There we go. All right, 36 respondents. Let's see what people had to choose there. And it looks like I didn't fool many people, but I got a couple. Got a couple of you roped in. Nobody believed it was the server that provides automatic IP addressing. That's a DHCP server. It's not a gateway. And it's not a repository of encryption certificates. Gosh, nobody even fell for my PKI. We just talked about encryption. I thought I'd drag some of you folks in. So the real question is it the destination address for all non-local traffic, or is it an intermediary server that processes internet requests? Well, in the IP world, a gateway is the router that gets you off your subnet. If you ever need to communicate outside of your local subnet, you use your gateway. So the answer would be the green one here, the destination address for all non-local traffic. If there is a server that sits between you and the internet, and you make a request of that intermediary server, and the server processes the internet request for you, that's a proxy server. That is not a gateway. At least not in the TCP/IP world of things. If we wanted to talk application gateway, we could have that argument, but I gave you a question that said in TCP/IP. So that is the answer, is the green number 30 here, the destination address for all non-local traffic. So that's one of the things that we think about whenever we're configuring a computer. We know that we have to have an IP address, we have to have a default gateway, we have to have a subnet mask. So the question that came in about that was from AC, and AC asked, can you have two gateways for a single host? Now that could be useful, right? Think about how you might be able to use that. You've got one machine, you've got an IP address and a subnet mask and a default gateway, but maybe you'd like some ability to use a different gateway. Maybe you'd like a way to, maybe if one gateway goes away, you can use a different one. But in the world of TCP/IP, it doesn't quite work that way. Let's first go through the ingredients you have to have on your computer. You have to have an IP address. Every device on your subnet has an IP address. Every device in the world has an IP address. So that is where you have to be able to identify yourself, and it has to be unique. On your subnet, nobody else can share your IP address. That's not what you want. For the machine that you're using, you also have to have a subnet mask, and that is used to help determine what subnet you belong to. You have an IP address, but that doesn't tell me how your network is split up. I want to know what specific network you are on, and it's the subnet mask that gives us that information. So at a very basic level, just to get a computer working, you need an IP address, you need a subnet mask. You really don't even have to put in anything else. If you don't have to talk outside of your subnet, you don't need a default gateway. But you'll notice if you're configuring these things manually, you need to also add a default gateway. And if you ever configured a default gateway on any device, whether you are in Windows or Mac OS or a Linux or a standalone device or a router or switch or anything you would ever use, you'll notice it only has an option for one default gateway. That's it. There is no other option for default gateway. And that's one of the things that is important to remember. This is called the default gateway. When your computer needs to talk outside of your subnet, it goes here. Now, a lot of devices, especially your operating systems, allow you to modify routes on your device. So you could say, if I'm talking to one subnet, go out one direction. If I'm talking to another subnet, go out a different direction. You can make changes to this, but your computer has to be configured with a default gateway. And that default gateway is a single IP address. So the question was, can I have more than one default gateway? You cannot. You can have one gateway. And you may be able, if you've got a very complex environment, you've got multiple network interface cards inside of your device, you would like one card, maybe you've got a wireless link, you'd like some communication to go out the wireless, you'd like some to go out one NIC, you'd like some to go out another NIC. You can make changes to your default routing table on your device. And that gets into a little bit more complexity about routing tables and default routes. We talked a little bit about that a couple of study groups ago, but that is a place where you can really completely customize how your traffic flows. But your default gateway, only one device. That is pretty much one of those things that that whenever you start working with computers and looking at this, it's kind of a limitation. It would really be nice, especially in today's modern networks, to be able to tell your computer in the IP configuration, this is your default. If it goes away, here's a secondary. If you've ever configured your DNS server, that's how you configure a DNS. Go to this DNS server first. If it's not there, it's not responding, go to this other DNS server. But that's the way we work. And in the chat room, you're bringing up a good point. The word gateway in TCP/IP is not referring to an application gateway, but we called it a gateway at the time. Whenever we built TCP/IP, we didn't know there was no router. We were making this up as we went along. We were trying to figure out, we were building a new protocol from scratch. So we called it a gateway. This is your gateway to the world. But obviously the term gateway in networking means so many different things. I think we generally, and I think generically, I think everybody really, what's your default route? What's the default router? We do sometimes say default gateway, but we really mean the router that gets you off the subnet. It is always a router to do that. Is everybody ready for another question? Because I have another one. Let's give you another question. I'm going to flip to this one. So I don't know if this one works either. just so you know, it's going to be a real mystery every time we plug in this number into our VOT.RS to see if it really is the right thing. So here's the question. What device is responsible for filtering and controlling incoming and outgoing network communication? Don't answer in the chat room. Do not answer in the chat room. So what device is responsible for filtering and controlling incoming and outgoing network communication? You can vote at VOT.RS. The number is 739583, 739583. 3. And if you have your QR code reader, pop on your QR code reader. You can take it from there. And when you get there, you're going to have some options. One option is gateway. One option is router. Is it a firewall or is it a switch? What device is responsible for filtering and controlling incoming and outgoing network communication? Is it a gateway, router, firewall, or switch? And one of the things you'll run into, especially when you start working with these network components, especially on the networking and security side, there's a lot of ways to filter. There's a lot of ways to do the filtering of content, filtering URLs, filtering IPS type vulnerabilities. We're not talking about those in this view. This is more of the networking infrastructure side. So you can, of course, absolutely start answering those questions on here. And we've got about 31 respondents. Let's flip over to this view. VOT.RS, number 739583. Let's see of this. And people in the chat room are complaining I'm giving them, the questions are way too easy. These aren't meant to be test questions. I'm not testing you on what you might expect on the exam. These are things that lead into the questions that you asked and to see if you recognize some of these things that we're saying. Not everybody knows. And if you're finding the questions really, really, really easy, maybe it's time you should take the exam. But I know when I started doing networking, and it was only a couple years ago, really, it was over 20 years ago, but I started doing networking. I didn't know what any of these things were. I was plugging in BNC connections from a mainframe. There was a token ring network. They were talking to me about packets. They were talking to me about gateways. At the time, it was a mainframe gateway. I didn't know what that was. We didn't have TCP/IP. There was no TCP/IP. We ran IPX and Novell servers. I had to learn TCP/IP because they presented me and said, here's a subnet mask. I said, what in the world are you talking about? With Novell, you plug in a device, it just works. You don't need these subnet masks and default gateways. This is very complex. This is very awkward to use. It's never going to catch on. This TCP/IP thing, it's so difficult. Nobody's going to use that. If you ever need any stock tips, do not come to me. Just telling you. So the options, obviously, here we go. Router, firewall, switch. I really didn't fool most of you. You all said firewall, and absolutely, it's a firewall. That's what we put right at the edge of our network to filter out the good stuff and the bad stuff and make sure the good things come through and the bad things don't. And the reason I bring this up is the question that came in. Oh, and by the way, before I continue, in the chat room, you're making notes of this. Again, I'm 60 seconds behind you guys. So one of the things you mentioned is that, yeah, but don't routers kind of filter? Well, in a way, I guess they sort of do. So if you answered router, there are ways in a router to filter out communication. So I'll give you credit for that one too. There are absolutely ways in most, I would say every modern router these days, to filter based on some very simple filtering based on packet filters. And I think that's a pretty important consideration because the question that came in was, what is the difference between stateful inspection and packet filtering in firewalls? Because those are two really different things. They at least in the security world, these are approached pretty differently. And for your Network Plus exam, you need to know the difference. It is specifically, I'm squeaking again, it is specifically talked about. Let's take an example of what these things are. And I think I have some examples on here. We're going to see if these actually will work properly. Now, let's say that we're going to talk about something called state in this particular set of examples. And we're looking at something that is a simple packet filter. A packet filter knows nothing of anything that's going on around it. It has some very simple rules that say if traffic is coming in and it is on a certain port number, allow it. If it's not on a certain port number, don't allow it. If it's coming from a certain IP address, allow it to come through. If it's going outbound to a certain IP address, allow it or disallow it. But it has no idea of context. It doesn't understand the communication that might have been set up already. It only knows to do a simple filter as it's coming by. It's the guy at the checkpoint saying, where are you going? Okay, go ahead. Now, if that car turned around and came right back through again, the guy at the checkpoint doesn't even recognize the car. Like, okay, yeah, where are you going? Okay, go ahead. Has no context whatsoever. Packet filters are stupid. They know nothing. They are completely ignorant of what's going on. And that's why when we talk about packet filters, they are stateless. They don't have any context. They can't keep track of the communications that are already in place and allow or disallow anyone from communicating. But when we plugged all of these networks in for the very first time, we didn't have stateful inspection. We'll talk about what that is in a moment. But we didn't have advanced ways to filter out traffic. We had very simple ways to filter out traffic, and that's packet filter. As that packet filter comes through, we allow or disallow based on a port number, allow or disallow based on an IP address without any context of what's going on. That's stateless. But we realize that lets the bad guys in pretty easily. They can almost try to slip in right in through an allowed port number and really start banging on a machine with all kinds of crazy packets. That's a problem. From a security perspective, that's an enormous problem. So one of the things we did with stateful inspection is the firewall, the stateful device, the device that is in charge of doing this, has a big clipboard. And as you're driving up in your car and he says, "Where are you going?" and you tell him, he writes down every bit of that information. Okay, you're a blue car coming from this side, your license plate is this, and you're going to this place. All right, go ahead. When the reply comes back, he says, "Oh, I recognize you because I just let you through, and here's your license number, and you went to that IP address. You're coming back from that IP address, your return trip. Okay, where are you heading?" You're heading right back to where you came from the source address originally. Okay, now it's your destination. That all matches up. I've checked your itinerary. It matches the reverse of what you were doing on the way in. You're going your way out. You're allowed to pass. Off you go. That's a much more complex set of filtering than we had with packet filters. Now, imagine you don't just have one person going in and out of your firewall. You have 1,000. You have 5,000. You have 500,000. That guy is writing a lot of stuff down. There's an enormous table inside of a stateful device, something that does stateful inspection. And every modern security device today does stateful inspection. Everything. Why would you do packet filtering? Do packet filtering maybe after you've done stateful inspection, maybe. Everybody's doing stateful inspection, but the machines have to be much smarter. They have to have a lot of memory inside of them to be able to keep this enormous table of who's going where. But the beauty is that if somebody out on the internet tries to send in a packet and that packet is out of a flow, it doesn't have a flow associated with it. It doesn't have a state in the table. As the packet comes in, we look at the table. I don't recognize your serial number. I don't recognize your license number. I don't recognize port number. I don't recognize anything about you. And you're in the middle of a conversation. No, you're not in the middle of a conversation. You've never come through here before, and I'm going to drop you on the floor. You don't come in. Really useful to have the stateful inspection. And if you're using and planning to use the Windows firewall, if you're using a built-in firewall on macOS, if you're using your firewalls in Linux, if you're using standalone firewalls, all of those devices are designed to be stateful. They're keeping track of all of those things. So I think that's when you start working with a lot of the higher end security devices. You're going to run into the stateful piece. And it really adds a little complexity. If you're trying to troubleshoot, imagine the complexity involved in trying to troubleshoot this. You now not only have to look at the packets going back and forth, you have to look at the table that's inside of your security device to see if it matches any of those packets. So it does add complexities to this, but really useful. Now, in the chat room, the question was, well, that's good. What about a proxy server? Yeah, proxy servers are a tried and true method of separating you from the internet. And in a way, a proxy server can provide a bit of this type of security, but even proxy servers are sending information in and out over known port numbers going out to the internet, but they're not doing any state analysis. You have to make sure your proxy server is protected from the world as well. So that's whenever it's not just the ability to replace stateful with something else. Everything you use has to really think about these states and be able to work with them. And you can add that stateful inspection with a proxy server. And now the security is the way you'd like it to be. Proxy servers are falling out of norm. It's not really the most modern way to protect people from the internet. They really don't protect people very well these days with the way that applications work. So, but still, a lot of people still using them, but you still need some type of stateful inspection going in and out of that proxy as well. I have another question for you. Get your QR codes ready. Here's our question. That is, What IP class was associated with the address 154.17.222.7? Go to vot.rs. You can vote at 684897. 684897. 684897. Go to vot.rs. This is, and notice I use the past tense. Which IP class was associated with the address? My inference, of course, meaning we don't really use IP classes anymore. Not even we don't use IP classes anymore. But back in the day when we used IP classes, what IP class would you associate with this IP address? And it is 154.17.222.7. No answering in the chat room. This is an important thing to know for the Network Plus exam. You need to know your classes. It does help to know this when you're starting the subnet process, because we generally start with what it used to be and we subnet from there. But it can create confusion. A lot of the times when we're dealing with subnet classes, a lot of people don't realize we don't use classes anymore at all, ever. So we are learned, we have to be taught these classes. And then you realize, what? We don't use them? They do have value, and we will talk about what that value is in a moment. But let's see what people have to say. So what IP class was associated with the address 154.17.222.7? It's a good question. I've got 36 respondents. Let's see what our results are. And you can see that the vast majority of you said Class B. I think we can probably say at this point that is a Class B, or was a Class B address. Some of you said that's Class A. Some said Class C, D, and E. But the answer for this particular address, 154.17.222.7, yep, that is definitely a Class B address. Now, why was that a Class B address? How did that work out? And there's a lot of confusion over addressing and subnetting, and why Class A and Class B and Class C. Because if you were to look at classes of addresses, it looks like everything should be a very particular subnet mask, and it should never change. So here, and I asked this question of you because here you go. This is a question from Jesse, and I loved this question. I have an IP address of 10.1.1.9 and a mask of 255.255.255.0, a gateway of 10.1.1.1. Now on his machine, he's also loaded one of the VMware virtual machine environments. And he has VMware addresses of 192.168.92.1 and 192.168.183.1, both with the Class C subnet, which means 255.255.255.0, and no default gateway, because those don't route anywhere. And he has VirtualBox also loaded on his machine. It's like my computer. Jesse's using my machine. VirtualBox address of 192.168.56.1, Class C mask. So far, everything's syncing up for Jesse, except the one up here at the very top, 10.1.1.9 on his local network, has a subnet mask of 255.255.255.0. Shouldn't it have a Class A subnet mask? Wait, we spend all this time talking about masks. And when I have the chance to apply it, because if you've done your research, and we'll talk about this in a moment, but if you've done your training and you look at 10.1.1.9 and you do that lookup in your head to determine what class that is, you say that's a Class A address. And you look at the subnet mask, and the subnet mask is the Class C subnet mask. What happened there? Let's talk about classes, because this is something really important when it comes to subnetting. And you don't have to do a ton of subnetting on the A+ exam or the Network Plus exam. We're doing Network Plus today. On the Network Plus exam, you don't have to do a lot of subnetting. You don't have to do any on A+. Let's talk about Network Plus. You only have to do a little bit. In fact, you might not get any subnet questions. You might get one or two. It's just a small, tiny, itty-bitty part of the exam. But let's talk about way back when we were first using TCP/IP. These big mainframes were connecting themselves together at these large educational institutions. They had built these networks between these sites, and they connected them together. And they gave the address and said, okay, you're going to be 10.1.1.1. I'm going to be 20.1.1.1. And we had the concept of subnet masks back then so that those devices could determine what subnet they were on, but we didn't configure a subnet mask. If you were able to go back in time and look at one of those big mainframes, it would say, what is your IP address and what's your default gateway? Where's subnet mask? I have to put a subnet mask in. They didn't have one because what they did was base everything on classes that said, if you are a certain range of IP addresses, you automatically get this subnet mask. If you're in this other range of subnet masks, or this other range of IP addresses, you get a particular default subnet mask. It's a class that you're assigned, and everybody in that class gets the same subnet mask automatically. You can't even change it. You don't even have the option to put in a different subnet mask. So if you're frustrated with the idea of subnetting a network, just go back to those days. You don't have to subnet anything. You don't have to do calculations of subnets and hosts, and you don't have to do any calculations. You put in an IP address, your computer machine automatically figures out the subnet mask from there. Obviously, we don't do that anymore. Now, if you were to break it down, the Class A subnet mask was one, if you're the first octet, we call it, that first section of the IP address started with 1 all the way through number 126, we called that a Class A address. And it got a default subnet mask of 255.0.0.0. So if you look back, and the question that Jesse asked was about 10.1.1.7 or whatever that was. Well, if we look at our list, 10 is definitely between 1 and 126. Therefore, its default subnet mask is 255.0.0.0, yet his wasn't. His was 255.255.255.0. And it was that way because he's not living in the past. There are no longer default classes for subnet masks. Now we can make the subnet mask something more appropriate for our computers. And the reason we did it this way, and we now have this classless subnetting, is because there was enormous waste when we did our subnet masks this way. Look at these ranges. If you have a default Class A subnet mask, you have a 10 dot address. That means on your network, you can have 128 networks and 16 million hosts per network. Nobody has ever had 16 million hosts on a single network. Class A was kind of a waste by itself. Without being able to subnet and break that up into smaller chunks, what a huge waste. You only got 128 networks to choose from, and you got 16. You're not going to have 16 million. You might have 100. And when we were using this in a class-based, you only had like 2. There weren't very many at all. Class B addresses are numbers between 128 and 191. Notice we skipped 127. That's your loopback address, so it technically doesn't really fall into a class. But if the number is 128 through 191, you can have 16,384 networks and 65,000 hosts per network. Still a waste. Yeah, I got plenty of networks. I'm never going to have 65,000 hosts on a network. And if Class C, this is what most people will configure their networks as, where you can have a bunch of networks, 2 million networks, and I can have about 254 hosts maximum per network. Well, for most people, that's probably pretty good. In fact, if you get above 254 hosts, it almost becomes a difficult management scenario because there's so many devices on a single subnet, all communicating, all sending broadcasts, that type of thing. So we looked at this back in the day when we had classes and said, well, that's ridiculous. We need to break these things up into smaller chunks. So we came up with this classless way of approaching this. And you look at the IP addresses for 192.168.1.1, you see the /24 at the end. That slash designates the CIDR block notation. And that means that you have 24 bits in the subnet mask. And I'm not going to go into the binary calculations of this, but there are plenty of videos that I have that step you all the way through the binary calculations and what 24 bits might mean. And what this really means is that you can have 192.168.1.0 through 192.168.1.255. Now, it happens to be, if you look at that, that happens to match the default old school Class C address. In fact, we still use these terms whenever we talk to people. They say, oh, you need to configure your machine. Yeah, I'll give you an IP address. Put in 192.168.1.1. Oh, what's the subnet mask? It's Class C. It's not really a Class C. We don't use classes anymore. But the subnet mask, what we're really saying is the subnet mask that you should put in is the one that was the default that we used back in the old days that is 255.255.255.0. It's almost more common these days, though, for us to go, it's a /24, because everybody knows /24. It's so even, 255, 255, 255, 0. We'll just type that in. We'll do the math. Sometimes when you're configuring a device these days, it doesn't even ask you for the normal decimal subnet mask. It just asks for the CIDR block notation. So you can just type in 192.168.1.1/24. You're done. You just configure the interface. Makes it a little bit easier to do that as well. Here's another one. 10.1.0.1/16 means that you have a subnet mask of 255.255.0.0. Again, you're counting those 16 bits to be able to do that. There's nothing that says you have to have just 8 bits or 16 bits. You can use as many numbers of bits as you would like then. So you could have a network that is a 10.1.0.1/26 if you wanted to. And it's 26 bits in the subnet. So this is where I think a lot of the confusion starts with subnet masks. Before you're even doing calculations, you're noticing the numbers don't even match up with what you've been told, because we spend so much time talking about and having you memorize what the classes are. And it's important to know those things, because when you start subnetting, it's nice to know what the default is and where you start from. But it's not a standard. It's not the default. We don't use that automatically anymore. In fact, your machines these days won't take a configuration unless you put in the subnet mask. You would use this type of CIDR block notation, this classless form of internet addressing. For instance, if you were MCI, you might have been given an address 208.128.0.0 with a /11 subnet mask, and MCI would break those things up. This is a very old example, but when MCI was around, they would break that up into smaller pieces. Here's the same address, 208.130.28.0 with a 22-bit subnet mask. That organization broke it up even further into a 208.130.29.0/24, and they'd finally give it to a device that was a 208.130.29.33. Look at the subnet mask on that /32, which means every single bit, which means it's not a subnet. That's a machine. Whenever you see a /32 at the end, it's really saying that's a box, that's a device, that's a server, that's a thing. That's one of those things that really, really helps to start before you begin the struggles of understanding the binary calculations that go into subnetting. Make sure you understand the difference between classful and classless, and understand we don't use classes, and think about how to do those binary equations. And quite honestly, once you kind of get that you can make it whatever you'd like, the binary part is really quite simple. It's addition and subtraction. There's no complex math involved. So pretty nice to have those there. One of the questions I get a lot with people that are trying to study for their A+, their Network Plus, their Security Plus, one of the things you've noticed almost certainly is that you now have more than just multiple choice questions. You also have questions that deal with a performance-based question. It's what they call them, performance-based questions. These performance-based questions are things that you have to perform. You have to type something at a command line. You have to build a network configuration. You have to fix a network that's broken by moving things around on your screen. And a lot of people are concerned about this because a lot of what we've been so accustomed to doing has always been based on some very simple multiple choice answers. But now I have to do something. Now I have to type something in. Now I have to really get into the details of how this works in an operating system, how it works at the command line. And one of the struggles, of course, is that very few of us have a big lab full of machines that we can start connecting together and bring up packet capturing and run ping commands and disconnect a connection. Does the ping command still work? We just don't have the infrastructure available. So I've worked with the folks at GTS Learning for years. They have always had great materials. In fact, every course that you take from me, I use their materials to build the course with their permission. I didn't just go out and do it. I worked with them. They said, yeah, use that stuff. Put it in there. It's fantastic. I work with them to get their multiple choice test questions. They have sample exams you can take. And they have labs available in a virtual environment. You don't have to build anything to make this happen. It's called Freestyle. And the labs themselves are pretty nice to use because out on the internet through remote desktop capabilities, you can now connect to and have an entire lab full of devices available for you to work with. And I've got this. I'm going to pull some up on my screen so you can have a feel of this, but I wanted to show you what these courses are like. And I find this useful because one of the things that they do with these is there's labs already set up. It takes you all the way through this. I'm logged into the modules here for the labs. There's configuring a network adapter, IP address configuration, ARP and packet analysis. That sounds like fun. I'm going to click on that one. Yes, I changed my screen resolution. So it's telling me, oh, we're going to do some remote desktop, so I need to know your screen resolution. Here is an entire lab set up, and I can go through. Here's the lab config. There's a server and a gateway and a router and a LAMP. That's a web server. And there's a client down here. Here's the boxes themselves. Here's the server. In fact, let's power on the server. Here's a client. I'm going to power on the server. Look, I'm just going to all these boxes and powering on the boxes. And they put a little orange light next to them when I power them on. So out on the network, on the internet somewhere, is a box that's now booting up. I don't have to have these in my lab anywhere. I don't have to have separate machines. I don't have to reconfigure them. And these boxes are built just for this lab, which makes it really simple. I don't have to even spend time configuring it or, in my world, misconfiguring it. And whenever I'm ready, I can always go back to the exam exercise and go, okay, what do I need to do? So I need to go through this piece, and I need to build out all of these, and I need to start working with the lab pieces for the network analysis. You see the gateway just came online. So let's go, and I want to go through and in that packet analysis, I want to be able to set some things up and modify some different pieces. So let's go to the gateway. Since it started up, connects to this device. I've got a remote desktop now that I can use to this server. There it is. It's a Windows box, all set up for me. I can run Wireshark, start it up. There it's running. Start up the interface. Oh, there's my server manager that starts up whenever I start the box. Okay, I'm capturing packets. There you go. It's not on my network. It's on the other network. I can see as those machines are booting up, as things are going by. Now I'm capturing the packets. It's all online. It's all with this remote desktop. And I can now step through the labs and go step by step. They even have screenshots you can blow up and go, where did I mess up? Tells me right there. Now, the reason I mention this is I've worked with these guys at GTS Learning to give us a discount. So if you go to professormesser.com/netlabs, I'm going to type it in on my screen too, professormesser.com/netlabs, it will take you to the GTS Learning site where the discount has already been applied. Because a lot of people will use these labs, and they'll think, well, I can't spend hundreds of dollars on having these labs here. One of the things that they have, they of course have books. In fact, I got a discount on the ebook, only $30. But here's the one. This has the Freestyle online learning and the practice labs. You get everything in Freestyle and the practice labs for $99. So I wanted to make you aware of that so that if you're trying to get through your Network Plus, and I get emails every week, multiple people saying, I really want to do this, but I don't have a lab for myself. Well, that's easy. You go to professormesser.com/netlabs, and we've got a discount already built into that. And I really like them. I've run through a number of them. I've talked to the organization that manages the servers. I've talked to GTS Learning about how they set up the labs and the Freestyle that they're using. A lot of good stuff there. And it does help Professor Messer as well. So it's nice to be able to partner with GTS Learning because they understand what we're trying to do here at Professor Messer. They've implemented my videos into their training materials too. So if you go through Freestyle and you're reading their book, my video pops up right in the middle. Kind of nice to have that there. And boy, just easy to use to pop through that. I'm already, let's see this, the client's up. Let's do another one. Since I'm kind of at the top of the hour, but I'm just going to go through the process of doing these. These even have Nmap in them if you wanted to do some scans of the network and start going through the IP addresses that are there and scanning those devices. They've already got a lot of the utilities already there and available to you. And of course, it's a Windows desktop. So if you want to go down and start a command line, CMD, there's my command line there. I'm running at a very low resolution on my screen. You won't have to scroll around on yours, but I do on mine because I'm in this view that allows you to see what's going on. I can do IP config on mine. Let's type that in. There's my IP addresses. My default gateway is 192.168.0.1. Can I reach it? Yes, I can. So now I'm command lining it. I'm now going through and running through the MBT stack commands and the net stack commands and all of the things you need to know for your Network Plus certification. All built into these labs. They take you step by step through every single piece of it. It's laid out in the same format as the Network Plus. Very easy to use. I really like what they've done with that. So you couldn't see any of that. Sorry. Flipped it over. Let me flip back to that so you can see. There's the command line. So you can flip back to the command line. Sorry. We are at the top of the hour, approaching the top of the hour. I recognize that. So I apologize for those of you that are expecting this to be an hour we're going to go over today. We go over a little bit. So we're going to now give you another question. So folks in the chat room have been saying, give me another question. I want to go through and have another one of these available. So I have another question for you. Get your computers ready. I'm going to make sure that I actually have the question for you for this. We're now going to go back to that very first one that I sort of gave you already, but I'm going to reset all of the results. So you're going to have to vote again at what is a DMZ? What is a DMZ? Well, this is a good question. So you can vote, and it's not 6. Let me flip over this. What a mess today with this. Go to vot.rs and enter 419274. Not 6. 419274 at VOT. You can't even see it because of my big head. VOT.rs. 419274. The options available to you for what is a DMZ. Is it a network area between the internet and the internal network? Is it the protocol used to share files over an encrypted connection? Is it the chipset used for 802.11 wireless networking? Or is it a high-speed memory bus? What are those things? What could it possibly be? It's a very good question. What is that? Yeah, it's one of those things that you're going to run into if you're doing any type of networking, any type of security, any type of working with applications, practically any part of an organization in IT where you're doing anything with the internet, when you're doing anything with servers, when you're working with protocols, when you're working with specialized programming applications, DMZ is going to be involved. You're going to need to know something about the DMZ. So what is the DMZ? What is that? Go to vot.rs number 419274 and vote on that. And while you're doing that, I'm going to take a sip. Thank you for indulging me. Okay, we got about 27 responses. I think it's time to get that. And have a look. Let's show the results. And I've already kind of seen these results because some of you already answered that. 29 of you have said the network area between the internet and the internal network. 3 said, oh, it's a protocol used to share files over an encrypted connection. 3 of you said high-speed memory bus. Nobody said the chipset for 802.11 wireless networking. And of course here, yeah, that's it. It is this area between the internet and an internal network. A DMZ, and you'll hear this term, it stands for demilitarized zone. The question comes from DT, who asked this month, what is this DMZ thing I keep hearing about? And if you're someone who is working with a firewall, you most certainly have a DMZ. These days, you'll even find the ability to do DMZs on your firewalls, your routers, your wireless routers that you would buy for your home. And what this is a middle ground. It's not on the inside of your network. It's not on the internet. But it's in the middle. It's in this demilitarized zone that we've agreed in this zone, there should be no war. There should be no fighting. And we're able to control traffic coming into that DMZ through a firewall. We're able to allow or disallow that traffic flow. So we can protect, at least to some degree, a number of the devices in the DMZ. And in most organizations, the only way that you would access a device from the internet is if that device is in the DMZ. Because there is also an internal network as well. That internal network almost always flows through the same firewall, but the firewall will only allow outbound traffic from your internal network. Your firewall doesn't allow inbound traffic onto your internal network. That's a no-no. If you've configured your firewall to allow traffic from your internet into your internal network, you're doing it wrong. You're doing it way wrong. The proper configuration of a firewall is to allow inbound traffic to a DMZ and into a DMZ only. And that's why it becomes very useful, is to have that there and be able to have that DMZ configuration. And if you're bringing up a web server in your organization, if you're bringing up a database server that's going to be accessed from the internet, if you're working with a device that is going to be accessible from the internet, you're going to put it in the DMZ. I have worked with people in the past that have had firewalls, and they say, well, we don't have a DMZ. And that's, really? They say, yeah, we don't. We really need one. Can you configure one for us? Like, let's do that right now. Let's have a seat and get your DMZ configured. I think that would be really, really useful if you had that. I think it'd be really useful if you had that. So that's a DMZ. If you don't have one, get one, make one, build one. And if people are accessing devices from the internet onto your home network, use the DMZ functionality of your home router as well. One of the things that we deal with a lot with the Network Plus exam, with any exam, is we have questions about the content, certainly, but we have more questions about the questions. What should I expect when I walk in to take this exam? What are the things I should expect to see? And I get a lot of those questions on here as well. One of the questions is, how often can you take the certification test if you fail the first time? This is something people like to know. I say, but you're not going to fail, are you? That's not what we're trying to work towards, is it? There is a retest policy at CompTIA. And if you use the Google box and you go to the retake policy is pretty well documented on the website. And you should check it when you're planning to use it, because it has changed through the years. If you happen to fail on your first attempt to pass any CompTIA certification, there's no waiting period between the first and second attempt. Before your third attempt or any subsequent attempt, you got to wait for at least 14 days. So if you missed it by a couple and you just want to go right back in the next day and take it, absolutely you can schedule that. But if you fail the second time, you got to wait 14 days. If you fail the third time, you got to wait another 14. Then you got to wait another 14. Then you got to keep going another 14. So that's one of those things. If you take the test and you're in violation of the retake policy, sorry, no credit towards that test. If you do this over and over again, I'm guessing this has been a problem, then you'll be banned from CompTIA in any of their certifications. Don't do that. You don't want to do that. That's important to know. If maybe you missed it by a couple of questions, maybe you went in, it wasn't your best day, you can turn around and take it again right away if you want to. I don't necessarily recommend that. Out on the Professor Messer website and the blogs, I have an article that says, I failed my exam, now what? And if you Google, I failed my exam, now what? Professor Messer, it'll take you to that article. And I give you a list of things to do. Check over this piece. Have a look at the document they gave you when you walked out the door. Make sure they give you even though you failed, they'll give you a document that says, at least in the domains, how many you got right and how many you got wrong. So keep that in mind too. Important. Another question that came in was, what main area would you suggest your students concentrate on for the Network Plus exam? I get a lot of questions on this. Okay, give me one thing I have to know. Tell me exactly what I have to know to be able to pass this exam. And the answer, of course, is there isn't any one thing. I wish I could give you that one thing that just study that one thing. The problem is that the Network Plus exam is broad. There is a lot of content on the Network Plus exam. And if you go to the CompTIA website, under the training and testing area, there is a section for exam objectives. If you have not downloaded the exam objectives, you must do this immediately. I was in a conversation on the chat room last night, and the person said, hey, I'm taking my test tomorrow, and I heard that this is on it. Is that true? You've scheduled your exam. You're about to walk in tomorrow and take the exam, and you have no idea what's on it. And so I said, well, you want to download the objectives right away. And he's, oh, yeah, I did that. Then you need to read the objectives, because there's no, I heard this was on the exam. It tells you what's on the exam. And let's do this. I'm going to flip back so my autocomplete doesn't Actually, this is just fine. I think they've really changed this form. You don't have to put in quite as much information. You say what exam objectives you'd like. I'd like to get, let's just do Network Plus for what we're doing and get the exam objectives. Now, I'm running in Chrome, so all I have to do, they have the older exam objectives here, the N10004. That's obviously not the latest ones. You want the N10005. I'm going to click that one. And because I'm in Chrome, it just brings up the PDF, doesn't have to launch a separate PDF reader. But the reason I mention this is the detail on here. It tells you exactly what you need to know for the exam from a percentage of the exam is on what topics. It's pretty good overview. 21, 23, 17, 2019, almost an even split across all 5 of the domains. So again, I can't tell you any one thing. I have to tell you all 5 of them. Now, let's go into the domains. What do we need to know? Well, for the OSI model, I need to know these things. Let's just scroll way down. Section 2.6, given a set of requirements, plan and implement a basic SOHO network. Know how to set up a list of requirements, what cable length you should use, the device types and requirements, the environmental limitations, the equipment limitations, and the compatibility requirements. That's the end of section 2.6. So if you were studying for your exam and you're going through this list and go, okay, do I know how to implement a basic SOHO network? And do I know the list of requirements, cable length, device types, environment, equipment, compatibility? Do I know these things? If I know it, I can put a big check mark. In fact, you may just want to print this out. Use it as a physical checklist. Yep, I know that. I'm going to check it off. Let's go to the next thing. Let's go to section 3, and we'll start going through these media types and those things. If I don't know it, that gives me some feedback on what I should be able to do to study for my exam. I think that's an important part of what you need to study for your Network Plus exam. Don't miss that piece. They give you everything. There's no questions about what you're going to be tested on. They give it to you. CompTIA probably does a better job than anybody at detailing exactly what you need to know. Very, very useful. Okay. One of the questions that came through about the exam is about the timing. Should I get my Network Plus before pursuing Security Plus? Would that be useful? It really depends on what you're trying to do. When I took my first CompTIA exam, mine was the Security Plus because I was in a role where I was doing security type work. I didn't have any security certifications, and part of my annual review was that I would be certified on an industry certification dealing with security. So I looked around and said, well, let's do Security Plus. So I didn't start with A+. I didn't start with Network Plus. I started with Security Plus. But I realized after getting Security Plus, I'm going to do Network Plus. And I did that one. Then I did A+. I went backwards. Did Security, then Network, then A+. CompTIA says you should do A+ first, then Network Plus, and then Security Plus. And if you look at the exam requirements, it does go through those exam requirements pretty well and follows them and kind of builds on it as you go. But it really depends on what you're trying to do. If you are in a role where people are asking you to get your Security Plus, that's great. But one of the things I really like about the Network Plus exam is that the information you're going to learn on this exam, you can use in every part of IT. You can use it in database management. You can use it in server administration. You can use it in security. You can use it everywhere. So the Network Plus is a really, really good certification just to have, but it's very nice to have the Security Plus if that's what you're doing. And people will say, well, how valuable is this certification? It may have no value to you, or it may have absolutely all the value in the world to you. It depends on what you're trying to do. If you're trying to move up in a current job and they've said, we need you certified, that's very valuable. If you're looking at job postings and the job postings say you need to have your Network Plus exam to have this job, Network Plus is going to be a pretty important exam. So have a look at what you're trying to do, compare that to what options are available to you and your personal knowledge of networking and security, and be able to apply that. Security really requires you know a lot about networking. So it may make sense to take Network Plus and then Security Plus. It depends on what you're doing. That kind of leads into the question that came from DS, which was, what certifications are preferred by employers? I wish there was an answer to this one. There's not. It's all over the place. I will agree there are people on the internet who say certifications are a huge waste of time. These people that are asking for certifications don't even know what they mean. They have no idea what these certifications are about. I think there's probably cases where that's true. Does not make them any less valuable, however. If somebody's asking you to have a Network Plus certification to get this job, I'd say Network Plus certification is pretty important certification. I don't think wouldn't call that worthless. I wouldn't call that a waste of time. And quite honestly, these are good certs. You're learning something in these certifications. It's information you're going to be able to use. These certifications are updated every 3 years. It's current information. It's things that are in use in people's networks today. They aren't teaching you token ring on the Network Plus exam. Nobody's used token ring forever. They're asking questions about gigabit Ethernet. They're asking you questions about public key cryptography. Those are the things you need to know about your certification. So I think that's one of the things. Don't fall into those traps of hearing people say certifications are a waste of time. If you go into a job interview and you have exactly the same experience and exactly the same training and education as another person who's up for that job, and you happen to have some extra certifications, you might be able to get the job just based on that. There's value with all of those things. You need certs, you need a formal education, you need experience. It's these 3 legs that you stand on. Any one of those isn't enough. Even 2 of them is okay, but not enough. Some of them have, I would admit, or certainly agree that experience is almost something that everyone wants, and it even trumps someone who's not experienced. If you have experience, you've already done it. I don't have to worry about you being certified. You did it. I really don't have to necessarily worry about a formal education. You already did it. I think long-term in your career, though, formal education really helps you move up. Otherwise, you're really stuck. And certification gives you that extra leg, gives you that extra piece to be able to make that work as well. Well, we have had a busy day of questions and answers, and we've come to the end of this Network Plus study group. I want to thank everyone for sending me those questions, the chat room for keeping me honest and dealing with the problems that we had with some of the questions that came through today. If you'd like to follow what we're doing, you can follow me. It's hard to read there, but at professormesser.com/YouTube, you can absolutely like those videos. It's great when you like my videos. I not only like it when you like it, but it helps me when I work with YouTube to do more things for you like these live streams. Also on Twitter, where I do my question of the day for A+, and I also put a few things out there every now and then at professormesser.com/Twitter. Google+, I am on the Google+, at professormesser.com/Google+. I make it so easy for you to find me there. Facebook as well. There's a wiki on the Professor Messer website now that you can read through, you can add to, you can help participate on the Professor Messer website. I also have a Dropbox that is getting very full. So this is sort of my piece at the end, that if you don't have a Dropbox account and you'd like to try it out, go out to professormesser.com/Dropbox. And if you sign up, they give me some more space. This is how I build all of these things that I build, as I stick them in my Dropbox when I travel. But I want to thank GTS Learning probably most of all. I've worked with these guys for years. They got great materials. You can go out to professormesser.com/netlabs to look at their labs. If you look at the Professor Messer website on the right-hand side, there's a 10% discount on your CompTIA exams. It's right there on the professormesser.com/vouchers, and it's a big box that's on every page you go to on the Professor Messer website, certainly on the main page, and that comes right from GTS Learning. So they were able to provide that voucher discount for all of you, and of course the questions I get all the time. You guys are great with providing me with some of those questions, and I think that's probably one of the things when I start working with and trying to figure out what am I going to do this week. I have no idea what's next, where I'm going to go with this. And somehow you always come through and you always provide me with the things that I need to be able to make that happen. So I want to thank you as well for having those and make them available. And of course, if you're planning on joining us next week, next Saturday, we'll do an A+ study group where we will do a similar thing as well. I want to thank everybody for joining us and having those here. I think that we had a very nice study group this week, and we're going to do another one next month. So look for those on the Professor Messer website as well. Thanks for joining us. We'll see you next time on the Professor Messer Network Plus Study Group.